Okay, we were supposed to, this is a continuation of our discussion on special types of regression, logistic at saka multinomial. Let's first look at another way, ito yung mga sabi natin mga let's say relatively modern techniques, a modern way to analyze our data, classification and regression. So we're going to make use of the party and RR part. Isa pang package dito yung RR part. Sana hindi, I don't know guys kung yung nabigay ko sa inyo yung may mga print out na answers. Pag meron, paki-Excel lang para tayo mismo yung mag-generate na answers. Okay. So please download the cardio dataset. Palitan nyo na lang yung dito, yung read.csv code dito kasi this is for my machine. Okay, so we're going to use the cardio dataset and let's view it. And ano laman itong dataset na to? 2,126 observations. No? 2,126 observations, and there are, I think, let's take a look at the glimpse. Download the main site. Kaya na-download sa site. If you haven't if you haven't accessed the site package, guys, library. Bagal pa rin talaga
Sorry sir, ano yung
package? Yung glimpse is site. To be sure, question mark glimpse. I think it's site. Just to know the structure of our data set. So meron kasi tayo dito LB, AC, FM, mga medyo strange na mga variables sa atin. Well, this is guys a data from the medical field. No? I'll explain in a while kung ano tong data na to, ano yung gusto nating i-predict. It's taking some time to. Bakit ganun lang? Yan. Bakit sa mga okay, so there are 22 variables all in all. And then yung mga variables dito, LB, AC, okay, hindi ko na yung metadata, no? I forgot to load it. But anyway, guys, what's important for us is the process, no? Yung meaning ng variables, we can just I can just send to you yung metadata nito. But this data is all about yung data ng sa sakit sa mga babae, no? So these are particularly some others. Yung NSP, guys, stands for normal, suspect, and pathologic. Normal, suspect, and pathologic, and it's all about what we're going to do here is to predict whether given these variables, mapapredict natin kung normal or suspect or pathologic yung case ng mother. Kasi this is about, if I'm not mistaken, fetal heart rate, pregnant women to. Tapos tinitingnan nila kung based on these variables, kung normal, okay, yung heart rate, suspect, or pathologic, ibig sabihin may sakit. No? So we have 2,126 observations and 22 variables. And yung variable of interest natin, NSP, is integer. Okay? And since we're going to do, we're going to predict si NSP, and since this is a factor, i-convert natin into a factor yung NSP na to. No? In a while, we're going to convert this into a factor. Okay, so we can do here, pwedeng multinomial, multinomial logistic regression kasi meron tayong more than 2 factors. Okay, remember last time kung dalawa lang yung factors na categorical, yung factor na pinipredict natin, of course, ang gagamitin natin doon binary. Ito naman, multinomial kasi more than 2 yung factors natin. But before we go to multinomial, tingnan natin kung saan tayo aabot. No? We're going to do first, we're going to make use para may taste na tayo ng machine learning tool. Okay, and one of the machine learning tools that's used is what we call decision trees. Okay, ang decision tree very powerful kasi pwede niya i-classify. Decision tree is an example of used in classification and regression. Okay, so the shortcut for that is CART, C-A-R-T. Okay, so let's go back to our file. So we took a look already at our data. Pero sige, run natin to. The structure, we have done that. Let me just run this one by one. Structure, okay, we have seen this, guys. It's a data frame. Okay, and yan, andyan yung mga variables natin. 22 all in all. Summary. Okay, so si LB, minimum 106, maximum 160. There are some variables here that are quite small. No? AC, FM, UC, these are very small value variables. DL, ito meron pa nga no? 0.0003, etc. These are measures, medical measures dun sa physiological na condition ng human. Okay, and then this is the response variable na titingnan natin si NSP. As I said, guys, N stands for normal, S stands for suspect, and P stands for pathological. And then we're going to make use of the party package. Let's try to see first kung ano ba yung dito. Hanapin ko si party. And if you haven't installed it, kindly install it. Package. Party. Okay. Oops. Nothing documentation on content. What this package does. What is a package? So look at this. Okay. Did you see any documentation on the party package? Okay, so the party package is a laboratory for recursive partitioning. So ito yung mga functionalities. So let's take a look at the description. Okay, party. And then a computational toolbox for recursive partitioning. So this is good for classification, pinapartition na. The core of the package is yan, C3, classification tree, an implementation of conditional inference trees, which embed three structured regression models into a well-defined theory of conditional inference procedures. So this is a very good package for classification, for regression also, and it makes use of decision trees. No? Okay, so you can look at the functionalities ng party package natin. Okay, I'll leave that to you guys. Here are some of the functionalities. Sabi, isa sa pinaka ginagamit daw dito yung C3. Ito, conditional inference trees. May C3 at saka may C3 control. C3, let's take a look at this. A recursive partitioning for continuous, censored, ordered, nominal, multivariate response variables in a conditional inference framework. So you can see, guys, that very flexible tong C3 na function. Kasi pwede siyang magamit kahit na yung response variable natin continuous, o pwedeng ordered, pwedeng nominal, and multivariate response variables. Okay, so we can, unlike guys, kunyari, pag regression, hindi yung LM function, hindi natin magagamit yan pag factor yung natin, yung response variable. Let alone kung multinomial, hindi natin pwede magamit si LM. We have to use another method to another function. Okay, ano nangyari dito? Nagtanong pala ako. Linode ko si party. Okay, so are you done, guys? Number one, have you loaded the file? So, andyan na ba si Cardio?
Yes, sir.
Okay, and then have you installed and loaded also the party package?
Yes, sir.
Okay, good. Ina, okay ka lang?
Yes, sir.
Okay, thank you. All right. So as I said, guys, si variable of interest natin si NSP. Categorical variable siya, and it classifies the state of the women into normal, suspect, or pathologic. So ang gagawin natin, guys, today is we're going to create a model that will try to predict kung based on these characteristics, based on the attributes, based on the other, on the independent variables, kaya ba natin ma-predict kaya ba natin ma-predict kung N o S o P yung natin, yung respondent, no? Yung woman na sinurvey. Okay, so let's first convert NSP. Let's create, here we're creating a variable NSPF, and then we're converting yung NSP into a factor. In this case, guys, preserve yung NSP, no? Kasi we're calling the new variable as NSP factor. So if we run this, run that and then check yung cardio natin, okay, you'll notice that meron ng panibagong variable dito, NSPF. Okay, NSPF, and if you check yung structure, natin, let me see, class, and then cardio, NSPF. Okay, factor siya, no? Factor siya, unlike yung class ni cardio, NSP. Ito, guys, NSP, this is integer. Okay, so we have created a variable called NSPF. Tapos ito, factor na siya. Okay, so let's proceed. Now, as you know, guys, when we do modeling, it's best not to use all your responses, no? It's best not to use all the samples. No? So ang gagawin natin dito, mag-create tayo ng ipapartition natin data natin. Let's call it PD, partition data, or any name that you want to use. And then let's just use 1, 2, 3, 4, set that seed. We know, guys, that you can use any number there. Okay, we have done this before, and let's use 80-20. Total malaki naman yung data set natin, ano? It's 2,000, saan na yun? Si cardio natin, 2,126. So 80% of that will be around 1.6. 20% of that will be around 400, ganun, 400 something. Okay, so we're going to use the sample function, and we're going to split our data into two. Ilan yung i-split? Ilan? It's the n row of our cardio. Okay, replace is equal to true, and then we're going to split it into 80-20. And then what we're going to do is we're going to create this object train, and it's coming from the cardio data set. And then yung PD, lahat ng partition data is equal to 1, that will go to train. And then we're creating another object called validate, or test. So all those that are indexed as 2 will fall under validate. Okay, so we can tanggalin na lang natin itong pag-print dito. I'm going to remove the printing kasi hahaba siya. Okay. Rather, okay, i-view na lang natin, no? View na lang natin si train at saka si PD. Okay, so let's run this. Okay, so meron tayong train dataset dito and validate. So train has a sample of 1,718. On the other hand, validate has 408. Okay, let's take a look at PD. So paano ba inano yung PD? Paano niya pinartition yung data? Here's PD here. Okay, ito PD. View na lang, view PD. Okay, so we can see here that this was how the data was partitioned. 1, 1, 1, 2, 1, 1, 1, 2, 1, etc. Okay, so lahat ng number 1 went to the training data set, and then lahat ng number 2 went to the validation data set. And if you view si train, so if you notice, guys, yung index na dito 1, 2, 3, 4, notice walang 5, no? Tapos isa 14 din yata yan. Okay, so this is our train data set, and our validate on the other hand will involve 5. So view natin. View, validate. So ito, yan, 5, 14, 16. Okay. So we were able to randomly split our data, partition our data into 2. Okay. All right. Any questions so far, guys? Ito sa pag-partition ng data. Chat naman, please, or unmute. Okay, guys.
So far, none, sir.
Okay. Thank you. Ina, how about you?
None for me, sir.
All right. So this is the first time we're going to make use of CART, classification and regression trees, in order to model our data. So we're going to make use of the party package that we installed just a while ago, and in particular the C3 function. Just to go back here, sabi natin, it's a recursive partitioning. So pinapartition niya yung data niya. So depende sa model natin into NSPF. Now for our purposes, no, unahin muna natin, guys. Let's just use everything. Okay. Mamaya babalikan natin to, but let's just lahat muna gamitin natin. Let's see what happens. Ang mangyayari kasi dito, medyo malaki-laki model natin kasi marami tayong variables. No? So anyway, let's just use that. So yung ano natin, yung classification tree number 1 natin, we call it 3.1, and then we're regressing the NSP factor into all the variables. Okay, and data is equal to, we're using the train data. And then ipiprint natin, ipa-plot natin, at saka tingnan natin kung ano yung simple na pag-plot. Okay, so let's run it one by one para makita natin yung result. So we now have this object 3.1. So ano ba yung laman itong 3.1 na to? Okay, ang sabi dito, it's a large binary tree. Yan. So that's the object that's generated from the C3 function. If we click this, guys, it's a, okay, sorry, 3.1. Training na ano ko. Okay, it's a list, no? 3.1. So andyan si data, andyan yung mga responses. Okay, conditional distribution response, prediction, okay, etc. So several elements inside this list called 3.1. Okay, so next, i-print natin, guys, kung ano yung 3.1. Let's print this. Okay. All right. So here, guys, sabi dito, conditional inference tree with 3 terminal nodes. Ang response variable natin, NSPF, ang inputs natin, lahat ng mga variables natin. Number of observations, 1718. Okay, then what do we have? Okay, parang simpleng-simple lang natin, ano? Okay, I don't know if this was just, okay, parang simple lang. We have NSP is less than 2. Now, for us to be able to understand this, guys, let's first take a look at, okay. Dapat, wag natin isama si ano, so dapat, sorry, i-minus natin si NSP. Okay. So NSPF regressed on all except NSP kasi NSP and NSPF are the same. Ulitin ko nga. Okay. Nagkamali, kaya mali answer natin kasi perfectly correlated si ano perfectly correlated si NSP at saka si NSPF. Kaya careful kayo dito, guys. Alright, let me pause for a while, guys. Nakita nyo kung bakit yung model natin, ang ginamit na predictor is NSP. Diba? Kasi perfectly correlated si NSPF with NSP. They're the same. Okay, so we should not have used NSP as a predictor. So pwede, it could have been better maybe if when we converted NSP into a factor, siguro mas maganda kung tinanggal natin itong NSP na to. In other words, we did not introduce a new variable. Okay, ginamit na lang natin, pinalitan na lang natin si NSP as a factor kasi that caused confusion. Okay, ako din, guys, ako na-confuse ako na short-sighted ako. So anyway, since na-introduce natin si NSPF, I'll just return that. And then what I'm going to do now is just make sure that hindi gagamitin na regressor si NSP. So C3 NSPF regress on all except NSP. So let me run this. Una muna. Okay, and then print 3.1. Okay, so okay. Ganun pa rin, no? Bakit kaya ginamit ko si NSP? Hindi naman dito. Ba't andun pa rin siya? Why is NSP still here? Okay, parang hindi niya. Okay, ayaw niya, guys, no? Ano notice niyo?
Yung, hello sir, yung
Yes.
dito sa file ko, yung model is NSPF to LBAC and FF.
Yeah, oo. Sabi ko, i-run muna natin lahat ng ano. Mamaya babalikan natin yan, yung model na yan. So what we're doing now is first running our NSPF using all the factors. Kaso guys, parang hindi niya binabasa itong minus NSP. Okay? Kasi may ano to guys, yung syntax ng hindi siya pareho ng LM, no? Okay, so I haven't done this before na minus ko yung isang variable using the C3 function. Usually guys, pag nagra-run ako ng C3, hindi ako nagma-minus. So when I did this here, I noticed na sinasama pa rin niya si NSP. Tingnan niyo guys ito, yung inputs. No? So kahit na minus natin. So I suggest that, okay, so gawin na lang natin dito sa ano sa pag-convert, okay? Okay. So first, tanggalin natin sa cardio si either, okay. Sige, para mas mabilis guys, i-load na lang ulit natin si cardio. Okay, so I'm discovering that for the first time na yung C3 yung function na yan, kahit na ibawas mo yung ano yung isang variable, hindi niya binabasa, no? Sinama pa rin niya si NSP. So why don't we just load the data again, si cardio. Okay, huwag nyo na i-view guys. Mabilis naman i-load dyan. So we can see here that cardio, yung data natin. Okay, so NSP lang siya, no? NSP. Alright, and then what we do is to convert. Okay. Convert na lang natin si NSP into a factor. Yan. NSP as that factor, NSP. Then let's run it. So if we take a look at the structure of class me cardio NSP. Okay. Ang class factor na siya. Factor na siya. Alright. And then i-run ulit natin to. Okay. Let's run this again. Okay, again, set that seed. Anyway, pareho yung mag-generate na ano yan, no? Na mga random numbers. And then let's see. Let's now run 3.1 and we're using NSP. Regressed on all the variables. Okay. Data is equal to the trained data. We're going to model our trained data. Let's run this particular tree, this line. And then i-print natin si 3.1. Okay. Yan. 23 terminal nodes na guys. So nag-expand yung model natin. Response variable natin is lahat. Okay. Lahat, no? Wala na yung NSP dito. Notice guys na yung terminal nodes natin, 23. Kanina, ilan lang yun? 2 lang yata. No? And now, you see guys that our tree is more expansive. Okay. Ano to, guys? Ano to? Okay, we will not discuss this as a tree, guys, like this. Rather, we're going to discuss this using the plot. Kasi ang hirap i-discuss ito eh. Suffice it to say, guys, that this is the path. No? So sabi dito, number 1, take a look at the variable DP. Okay? And if it's less than or equal to 0.001 for, you go to criterion 1 siya. Pupunta siya sa criterion 1. And then take a look at, if it's not less than or equal to this amount, pupunta ka ngayon kay ALTV. Titignan mo if ALTV is less than 68. If so, criterion 1 siya. Okay? Tapos, you see guys that it goes on and on. No? Hanggang 23 yung ano, 23 yung sabi niya, yung terminal nodes. Yung terminal nodes guys, yun yung decision nodes na. Okay? So it's quite difficult to see it here using this format. Yung conditional inference tree. Now it's best to use this using the plot. So tingnan natin guys. Medyo magiging ano din yung natin yung yung plot natin medyo maging expansive din kasi 23 yung terminal nodes natin. Let's run this. Okay. So medyo nakakalito, no? Yan. Let's take a look at that and print nga natin to. Zoom natin. Okay. Ayan. So, medyo guys, medyo mahirap siyang intindihan kasi malaki yung natin. Malaki yung tree natin kasi sinama natin lahat ng variables, no? Uh, uh, just to explain what this is, guys. Ito yung number 1 node, no? This is number 1 node. So, ang sabi, if dp is less than 0.001, okay, saan pupunta? Go to ALTV. Okay? And then if ALTV is less than 68, ito yung nakita natin kanina dun sa textual na tree. If ALTV is less than 68, go to ALTV again, no? And split this whether it's less than or equal to 7 or greater than 7. If it's less than or equal to 7, then go to mode. Okay, if the mode is less than 91, then ito na yun, guys. Ito na yung terminal node, node number 5. Okay. Hindi natin kita kasi hindi natin ma-print yung buong yung buong tree. Okay, but it should tell us kung ano yung mga dito, ano yung mga decision. Kung whether the terminal node class will tell us if it's normal, suspect, or pathologic. Okay, so you notice the tree being yung tree na ginagamit natin as a model to predict whether it's N or S or P. So in this case, if it's on the other hand greater than 0.01, you take a look at the mean. If the mean is less than or equal to 1, then go to this node 44. Okay. If it's greater than 1.08, then go to this node 45. Okay, so let's see if we can have a better representation of this. Okay, so let's use plot 3.1 type simple lang. Tingnan natin kung mas maganda to. Okay, maganda siya, mas better dun sa una, kaso parang ang hirap rin basahin. But let's just see. This is just the same. Okay. So, for example, guys, ito, no? dp is less than 0.001. Punta tayo kay ALTV. If ALTV is less than equal to 68, punta tayo dito. And if ALTV is less than 7, then mode, itong node na to, no? Mode titingnan pala. So, if it's less than 91 to, kasi greater than 91 to said. If it's less than 91, the decision is here. Okay. Alright, hindi din natin makita itong the numbers here, guys, tells us of the probability that it is normal, suspect, or pathologic. Ito yung NSP. Ito pala, no? Dito, kita pala. No? So dito, itong node na to, which is node 5, what's the result for this one? It tells us here, under this node, there are 14 of the total 1,718 dito punta, no? And the probability that it's normal is 7%. The probability na suspect siya is 0, and the probability that it's pathologic is 92.9%. Okay? So anyone that falls under this, dito sa dito sa line na to, pababa siya, meron pang less than 91, the chances that this will be pathologic is 93%. Okay, so therefore, ang prediction nito, this will be P siya, pathologic. If we go here, guys, okay, We just have to follow where that line goes. Okay? Dito sa node, sa terminal node 18, so 90.91% normal siya. S is 9% and then 0 is 0% na pathologic siya. Okay? Any questions about this, guys? We'll just have to find a better way to print this kasi nag-overlap na. Okay, clear so far, guys?
Yes, sir.
Okay, so straightforward naman yung pag-interpret sa kanya ng classification tree. Teka muna, may tanong lang ako. Have you met this model before in your previous subjects?
Not
Sorry?
yet, sir.
Wala. Na first time yung gagamitin kung ano to. Si party
Yes, sir.
package for, yeah, that's good. No? So maraming take note, maraming pwedeng paggamitan to. No? Itong, kasi
Sir,
pwede siyang,
question.
yes.
Yung part package, yun yung most common pag ganitong decision tree yung
Hindi, may iba pa. May iba pa. Kasi decision tree is just one of them. Merong mga support vector machines, merong pang isang package yung fast and frugal trees FFT. We're going to also make use of that. No? Titingin tayo, gagamit tayo ng iba't ibang klaseng classification tree na packages. In fact, isa to sa pinaka-basic yung C3. But of course, it has its use also. Okay, so let's see. Okay, thank you for asking, Chard. All right. So i-X ko muna itong result dito, no? Close ko muna. Okay. Now, pwede natin guys, pwede natin ito kasi, no? Yung ginawa natin dito, linahat natin. Okay, balik natin lahat. Okay, so you can, guys, pwede natin i-control yung tree. Pwede natin, what we can do is, we can increase the minimum criterion. Pag ginawa mo kasi yung minimum criterion, in-increase natin, ang mangyayari niyan, the effect is, kasi 95% yung default, the effect is, it makes it, mas magiging, mas simple yung tree, kasi it makes, pag 99%, it captures more data in its, sabi natin, in a node. Okay? Unlike pag 0.9 guys, mas ginagawa natin restricted yung pag-classify into a particular node. So, para mas lalaki yung para mas lalaki yung model natin. So, let's try this. Itong ang bago dito guys, yung controls, no? Yung C3 control. So we can control the kanina kasi yung terminal node natin 23. So ibig sabihin 23 different criteria, no? in order to determine whether N, S or P yung isang sample. So that's 23. Ngayon, what if we decrease the default 95%? Tapos tingnan din natin, ibig sabihin ng mean split, mag-i-split lang yung data kung there are 50 that belong to that specific category. So sige, i-run natin. Let's run this first, yung first line, yung 3.1. Okay, oops, ano nangyari? What happened here? Sorry. 3.1.
Naka-NSPF.
Thank you. Tama. Nalimutan natin na NSP na pala tayo. Okay, ilan natin. Okay, tapos print natin si 3.1. Notice what happened guys. No? Actually, bumaba yung terminal nodes natin. Okay, kasi, bakit siya bababa? Kasi kanina, yung mga number natin na pumasok dun sa terminal node natin, na-notice nyo? Iran ko itong yung isa, yung sa 3.1. Okay. And then, yan. Sorry, this one. Yung plot natin. Right? If you take a look at the N here, hindi kita masyado. May mga kasama dito sa ano na to, sa mga nodes natin na less than 50. Yung N is equal to dito yata. Dito sa dulo, sa simple lang. Ayan, N is equal to 33, N is equal to 11. Okay, if I'm not mistaken, guys, if I recall correctly, yung mean split, it will make sure that ang pwedeng pumasok is 50, no? Bago siya magiging bago siya magiging split, no? Okay, tingnan natin. Okay, naglan na ba to? Okay, 22 to, no? And then let's see. Dito na ako sa dulo. So, no? Sorry, mali interpretation ko. Mean split. Okay. Hindi siya dun sa number. Ang mean split sa C control siya. Ang mean criterion is mean split. Let's see if we can find the definition ito. From what I recall, no documentation kasi dapat titinan talaga natin sa RT package. Anyway guys, let's leave that for a while. Now, tingnan natin guys kung anong difference ng mean split na 50 sa 500. No? Kasi ito yung minimum criterion, ginawa ko 99.99%. So let's see this. Again, baguhin natin to. And then ito. All. Okay. So let's run yung 1B. Okay. And then dito. So you notice guys what happened? Nag 8 terminal nodes na lang siya. Okay. Hindi na yung 23 kanina, ang dami nun, di ba? Ang dami nun. So we can adjust the number of terminal nodes, okay, by increasing your minimum criterion and your minimum split. And if you look at the simple plot ng tree natin, okay, there. It's a lot more simple. So nangyari, mas naging simple yung model natin. Okay, dito, for example, start with DP. If it's less than 0.01, go to ALTV. If ALTV is greater than 68, then you have this terminal node. Yung mga terminal nodes, guys, ito, 1, 2, 3, 4, 5, 6, 7, 8, the one grayed out, this will tell us, guys, kung ano yung prediction natin. So this one, if it satisfies these conditions, DP niya less than 0.001, ALTV niya greater than 68, then 94.6% it's S, it's P, pathologic. Okay, so there. Ito yung natin, ito yung mga terminal nodes. Alright, so mas na-simplify, no? Mas na-simplify. So kaysa kanina ganyan, na 23, no? Yung una natin, 23 terminal nodes. Okay, what if we make it 0.99? Tingnan natin, guys. So let's run this again. Na 99 lang siya, 0.99. Let's see if it will increase a bit. No? And then print natin. Ayan, medyo nag-increase siya, naging 10 nodes. No? Kanina 8. So, and so ang question, ilan ba yung optimal? Well, again, it will boil down to your study. No? Kung may mga studies kasi na dapat very specific na na yung criteria natin talagang kung tawagin natin sa Filipino, yung masinsin talaga. Talagang napaka-specific down to the nearest details. No? So siguro mas maganda nga yung mas malaki yung classification tree because and it will be good to compare. No? Remember guys, di ba may confusion matrix tayo. As an exercise, it will be good to compare. Mas maganda ba kung yung natin, mas tama ba yung na-predict kung mas maraming terminal nodes? Theoretically guys, mas sabi natin mas siguro mas tama yung ano, yung mag-predict nun. Kasi mas marami kang criteria na tinitingnan. Okay? So mas comprehensive yung tree natin, yung classification tree natin. Vis-a-vis this this type of classification trees where our terminal nodes are fewer. Kanina 23. Tapos ngayon, yung isa natin yung 99.99%, 8 lang. Ito 99%, 10. Okay, so again, the determination of whether how many classification trees you want, how specific it is, will be dependent on the nature of the study that we're conducting. Okay, siguro sa efficacy ng mga drugs, for example, siguro mas ano, or sa sa state ng health ng isang tao, siguro it really matters na talagang tingnan natin yung ano, yung very say very, what's the term for that, very fastidious or very critical yung ano, yung pag-determine natin ng ano, ng mga terminal nodes, because it has something to do, maybe it's critical to the diagnosis or to the health management ng tao nyo, kung ano yung mga medicines, etc. I'm just thinking out loud, guys. But that's true, no? That's true na mas maano yung ano, mas critical yung study, mas maganda kung mas maraming ano, mas big, mas wide yung ano natin, yung classification tool. Okay, so so far guys, clear yung paggamit natin ng minimum criterion, yung C3 control. Guys?
Yes, sir.
Okay, andito yung sa ano natin, di ba? Ito, sa usage ng C3 natin. Controls is equal to C3 control, which we used to. Alright. So, okay, let's go here. Okay, now i-test naman natin guys yung 3.1b natin. Ano ba yung 3.1b natin? 3.1b natin is we're using all, di ba? All the variables. Pero ang minimum criteria natin, gawin na natin 0.99, no? Minimum split 500. Okay? But here we use the training data, di ba? Now, gamitin natin to sa testing data. Okay? Kasi this is already our model. Ito yung model natin. Tapos gusto natin malaman kung how effective this model is if we're going to use this for the data that has not yet been seen by our model, itong 3.1b. Tingnan natin kung effective ba siya kung wait. The train, tapos ito wait. Testing, okay, sorry. I-predict muna natin guys, no? Let's predict first. Kasi na-model natin, tapos tingnan natin kung how it will compare. So how do we do that? Let's create this object P1 T. We're going to predict using the 3.1b model on our trained dataset. Okay, so hanapin natin yung head ng P1T, compare natin sa head ng train and then yung NSP lang. NSP. Okay? Wag yung buong wag yung buong train data. Gusto lang naman natin i-compare yung yung prediction. Okay. Sandali, run nga natin muna to. There. And then head ng P1T natin will be yan. Okay? Alright guys, ito we can make this as pwedeng type is equal to response. Let's see. Type is equal to response. So pag type is equal to response, so if you run this, control enter, and then kunin natin yung head. Oops, run, control enter. Response, okay? Tapos yung isa, probability. Let me check this. Okay, alright. So yun ang difference, no? We can predict kasi using response and using probability. Okay. So sa probability guys, So si number 1, observation number 1, asan si observation number 1? Okay, sige, i-head ko siya. Head natin si observation number 1. Head. Head itong train. Okay, so, alright. Ito yung ano natin, yung actual. So si observation number 1 kay train dataset, actual niya, suspect siya, di ba? Normal, 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 pathologic, pathologic. Yun ang actual state ng natin, ng observation number 1 natin. Tapos dito, 0.54, normal, no? So ang prediction niya dito, 0.54, 0.42 as suspect, 0.03 as pathologic. So mali siya dito, no? Tama ba guys? Mali siya sa prediction niya sa observation number 1. Correct guys? Hello? Kasi ito, 2 siya dito. 2. Diba? Pero ang probability na magiging 2 siya is just 0.42. Ang prediction niya, 0.54 siya na normal. Right?
Sorry, sir. Okay lang pa ulit.
Ulitin ko, okay. Sige. When we, yung ano natin guys, yung train dataset. Actually, ito yung train dataset natin. This is our train dataset. Train dataset. Asan mo sa train ko? Mas ko to. Ito. If you take a look at the actual guys, number 2 siya. No? Ano ibig sabihin nito? Suspect. Suspect yung state ng babae na to. And then normal. Diba? But when we look at our prediction, ang prediction natin based on the probabilities is based on the probabilities is 0.54, no? Okay. Tanggalin ko to Tanggalin ko tong type, ang ano niyan, ang default niyan is response, no? Okay, ito, no? Para simple na lang. So, ang prediction guys natin, normal siya. Bakit 1? Kasi yung probability na 1 siya is 0.54%. Tama ba, guys?
Okay, sir.
Sandali lang guys, may ano lang, siguro may delivery lang sa atin. Just a minute.
Okay, sir.
Okay, thank you for waiting, guys. Huh? All right, so we were talking about the prediction based on this classification tree which we used. So ginamit natin yung NS, yung 3.1b, where the minimum criteria was 99% and mean split natin 500. And then ito, guys, di ba, ilang terminal nodes? So 10 terminal nodes. So we compared the predicted value with the actual value. Paano natin i-predict? We're going to use the predict function, and then the model is 3.1b, and the data that we're using is string. Okay, so sabi natin, i-predict remember guys, dalawang type ang pwedeng generate natin yan. Yung type is equal to response, or type is equal to class, which will give us the classification 1, 2, 3, or just don't type it there, or type is equal to probability. Ibibigay sa atin yung probability. Okay, it depends on what we need. So in this case, gusto lang natin malaman kung ano ba yung prediction. Okay, so I'll run this. Lahat na. Okay, so ito yung yung prediction 11133. Ito yung actual 21133. So sa first observation mali yung prediction, no? Pero yung next 5 tama. Okay, so what do we do with this now? Okay, mako-compute natin guys kung ano yung misclassification, no? Okay? So let's now create a table. We'll call it tab.1a. So ang function natin table, where we're going to plot on the y-axis yung predicted, itong 3.1a. Okay? Predicted, and then sa yung actual sa x-axis, and then we have to use, sorry about this, NSP, no? Kasi wala na sa NSPF. Okay, actual is equal to NSP. So this one, if we print this, okay, let's see. Parang ito yung dati, no? Yung classification matrix, confusion matrix natin. Okay, so...
Sir, sorry, hindi ba 3.1b yung tinitignan
saan?
natin?
Which one?
Hindi ba tayo nasa 3.1b?
Ay, oo, nga pala 1b tayo. Sorry, ha? But of course, you can still use 1a, ha? 1a. In fact, pwede rin natin no? Baka kaya yung 1a ang inano ko kasi nag-1a ako dito. No?
Meron ata sa baba, sir, for 1b din.
Meron din?
Yes, sir. Na-miss nyo na, sir. Nandun sa baba mismo naman. Ayan.
Ito, no? Sige. So let's use 1A first, no? Para I think ang ginawa ko dito para consistent, no? Para madali ko ma-identify. So tab 1A will be the model for that 1A. Okay, and then we're going to create the confusion matrix. Gusto natin malaman kung ano ba yung tama na predict na model natin for classification 1, 2, 3 compared to the actual. So when we run this first 2 lines of code, ito yung lumabas. So ang tama niya, okay, ang actual, predict niya na normal, tapos actually normal siya, 1309. So this is correct prediction. 161 for number 2, and for number 3, 136. Okay? So ang mga tamang predictions natin, diagonals, diba? That's why we can actually compute it. Ilang percent yung tama? It's the sum of the diagonals of our table 1.a divided by the sum of the total, which we're expecting to be 1718, no? 1718 siya. Okay, then yung reverse na yung maling prediction. Okay, so print na lang natin lahat to. So 93.5%. Okay, yung correct na prediction niya. And then just 6.5% na wrong prediction. Okay. Ano tong model na to? 1A where we use all the models, diba? All the variables. And then there are 23 yung terminal nodes natin. No? Ibig sabihin, hindi tayo naglagay ng control dun sa ano. Yung default is 95%. Okay, and then as many tree na pwedeng yung minimum split walang restriction. Okay, so we're getting a 93 around 93% correct prediction vis-a-vis 6% na wrong prediction. Okay, now how about that 1B? So that 1B naman nagbigay tayo ng ano, di ba, ng restriction 99%, right? Am I right? 99% ginamit natin. Okay, yung minimum criteria natin 99%.
Yes, sir.
And minimum split na 500. Okay, let's see kung may difference ba kung dun sa pagko-control natin ng 3. So let's call it tab that 1B, and then again we're calling the y-axis as predicted and the x-axis as actual. Okay, tanggalin na naman natin itong F na to. Okay, so let's print everything. Let's run everything. Okay, let's see. Okay, so dito guys, notice natin na, okay, notice guys na kapag linimit talaga natin yung ano, no, yung nodes na where we can predict yung ano natin, yung state ng sample natin, you'll find out that yung sa 2 nga guys, sa 2 wala siyang tamang na predict, ano? Wala siyang tamang na predict sa 2, sa suspect. Okay? And then the the percentage of correct prediction is 84%, tapos yung mali 15%. So guys, it's really a toss up between kasi paano kung 100 yung ano natin, yung terminal nodes. Well, actually pag automated na guys, ilalagay mo lang naman yung ano, we'll just key in sa computer kunyari yung parameters, no, yung mga variables. And then it will automatically, based on that particular model, generate kung ano yung predicted value, kung N ba siya, o S ba siya, o F ba siya, no? O P. And of course, guys, given if you're comparing yung accuracy, if accuracy is really very, very critical, kunyari nga, we're dealing with the research on health issues. Tapos medyo kailangan yung accuracy medyo mataas, no? So, no-brainer naman na ang pipiliin mo kahit na medyo mas besides guys, ang gagawa naman yan ng computer. Hindi naman natin manual na isa natin susundan yung 3. Kaya imagine guys kung kung manual nga lang. If that was the case, then siyempre pipiliin natin mas simple 3. Do you agree with me guys? Hello?
Yes, sir. Yes, sir.
Diba? Kasi kung mas complicated yung 3 natin, tapos i-manually natin isa-isa to determine whether a particular observation is N, S, or P. Imagine kung yung depth ng 3 natin, 10 layers, no? Isa-isa. You'll go to different layers until you reach the predicted value. Okay, but in this time and age, hindi na naman ganun. Okay, so let's go to the next one. Okay, so let's use 3.1a to predict the validate set. No? So the validate set, remember, ito yung sa partitioning ng data natin. This is the data that has not been seen by your model. Okay, so P1 validate. Okay, we're going to use predict 3.1a, the validate data set, and then tapos yung head ng validate dapat lagyan natin yung NSP. Para bigay lang niya yung either 1, 2, or 3. Okay, so same thing here. Okay, but this time, ito sinubukan lang yung probabilities. Ano? This is what I showed you a while ago. So malaki to. P1V, which is the prediction, that P. Okay. Predict. Ito kasi yung ano to, yung class, no? So if you run this, run muna natin to. Okay. Sama na natin pala to. Okay. Let's see how it compares. So validate, guys. Yung first 6 observations, tama. This is the prediction 111331. This is the actual 111. May mali pala. May misclassification isa. 111332. So on the 6th observation, guys, mali yung prediction. Okay? And just to illustrate, guys, ito yung sinabi ko sa inyo, ano, yung probabilities. If you run this, okay, this gives us the probabilities. So probability na normal siya, 99%. Okay, so the first 1, 2, 3, the first 3, 1, 2, 3, 1, 2, 3, 1 yung prediction niya. The next is 3, 3. 3, 3, 3, 3, 1. 3, 3, 1. But actually, it's 3, 3, 2. So dito siya nagkamali ng prediction. Okay, so that's just a repeat of what we did a while ago. So let's now go to the classification, yung confusion matrix natin. So we're going to create this, we're creating this table, and it's that 1A validate. No? Predicted is 1V and SP. Print natin. Okay. Let's see, guys, let's print this. Okay. So 92%. Kanina yung ano 94 ba? 93. 93. Tapos sa validation 94% yung 1A natin, 92%, di ba? Not bad. Okay? Not bad. So the model was able to predict 92% correctly yung isang data set natin na which has not yet been seen by the model. So, yeah, very good. Very good yung model natin. It was able to predict almost as good as the training data. Okay? Guys, clear?
Ay, sir, sorry. Hindi lang nag-run yung ano.
Which one?
Yes, sir.
Which one? Ito?
Itong code, sir. Wait lang. Check po yung difference.
Sige, ikaw nga mag-share, Chard. Stop share ako. Hindi ko pa kayo nagagawa ano. No? Let me make you as co-host. That is Ina. Just in case you have some questions. Yan. Okay, Chard, pwede ka mag-share ng screen.
Okay, sir. Nakita niyo, sir?
Yeah.
Ito, sir. Hindi ko naman nangyari. Baka dito sa taas.
1A. Okay. Ano ba yung 1B?
Same error sa akin, sir.
Error din?
Yes, sir.
Sige, i-check ko ulit ha. Chart.
Sige, sir.
Ako muna mag-ano.
Okay po.
Sige. Tingnan natin. Let's check kung saan tayo nagkamali. Okay, sa akin, ba't ko muna? Ba't nagdan sa akin? Okay. 1V, tama ba yung 1V natin? Tama, 1V. 1V, predicted 1V. Actual natin, validate and SP, tama. So, i-print natin tab.1AV. Tama. Tama naman. Yung table natin. Sinam natin yung lahat ng elements ng table. Could you compare guys kung tama yung ano? Anong sabi sa sa comments, Chard? Yung ano?
Sige sir. Sir, hindi kayo naka-share, sorry. Hindi nakita.
Ano yung, hindi, may comments dun eh. Ano yung sinabi?
Error in order Y, unimplemented list in order vector 1.
Vector 1. Error in order 1.
Y, sir.
Why? Sige nga, ulit nga natin. Ikaw nga ulit mag-ano. Sandali stop share ako. Stop. Ay. Wala akong naka-share. Error in head. Ito. Dito pa lang kasi sa una. No? Object
Okay.
P1V not found. Dun pa lang. P1V.P. Sige nga.
Ito, sir.
P1V.P. Kasi dinistinguish natin yung P1V.P, no? Dinistinguish natin yung P1V.P, probabilities 2. Tapos, lagyan mo nga ito chart ng ano, P1V.P, yung sa 98. 98, row 98. Yan. Kasi .P yung nasa head natin. Sige, run mo yan. Yung dalawa lang, yan. Sige. Tanggalin mo na lang yung sorry, Chard. Tanggalin mo na lang yung parenthesis dun sa P1VP. Sa 98, tanggalin mo yung parenthesis. Kasi ipiprint na yung ipiprint na yung buong yan eh. Sa dulo.
Okay, sir. Ay, wala bang error
Sa dulo. Tanggalin mo rin yung parenthesis sa dulo.
dito?
Yan, Yan. Tapos iprint,
Ay, sorry.
sige, i-X mo na ulit. Yung dalawa na lang. Yung 98 at saka 99. Yan. Yan. Sige, run mo yan. So, tama na, no? Diba? Nag-run na siya.
Yes, sir. Walang error.
Tapos, dito, check natin yung natin. That one A.
Yes, sir.
Yan na. Bakit nagkamali kanina? Ba't 79
Okay,
lang sa'yo? 79% lang yung wait. Tama, validate to, no? Validate na. Ina, nag-run yun sa'yo?
Hindi pa, sir.
Hindi pa rin? Nag-error pa rin?
Yes, sir.
Sige. Tingnan naman natin kay Ina. Sir,
Okay, sir.
check natin kung bakit 79 sa'yo. Let's decipher that. Ina, kindly share your screen.
Ayan. Kita niya ba, sir?
Yan. Error in one.
Yun din, sir. Pero, tinry ko na yung P1V.P.
Tama naman siya. Type is equal to, nag-run naman siya, di ba? Yung one
Nag-run
host.
naman. Yes, sir.
Sige, baba nga. Nag-run naman yung mo, di ba? Sige, baba nga. X mo muna yung yung probabilities. Yan. Okay. Tapos, we're now here sa misclassification. Okay. Ang predicted natin, dapat walang .p. Kasi probabilities yan eh. Dapat ang kino-compare natin yung actual, yung response, no? At saka yung actual.
Okay.
Yan. 92. Chart, pareho kami ng pareho kami ni Ina ng result. Okay. So, okay na yan, Ina. Tama.
Okay, sir.
Chart, pakita mo nga ulit yung output mo.
Share.
So while Richard is sharing, Ina yung mali dun yung yung .p, no? Kasi yung .p, probabilities yun ang generate. Di ba?
Yes, sir. That's
Tapos, yung isa naman, yung validate natin, $NSP, yung mga yun, yung mga 1, 1.
Yes, sir.
Oo,
Mga
so
response.
talagang yun. Hindi siya, otherwise, zero yung mga natin, zero yung mga prediction natin.
Oo nga, sir. Let's go na.
Sige. Okay, si Richard naman, predicted is equal to P1V. Tama naman, no? Actually is equal to validate NSP. That one AV, some tab 1 AV. Okay. Chart, i-run mo nga ulit yung ano, i-run mo ulit yung 95 and 96. Tanggalin mo na, Chart, yung ano, tanggalin mo yung, oops, sorry.
Sorry, sir.
Tanggalin mo yung parenthesis sa P1V. Kasi piniprint pa ulit kasi niya, no? Sa 95. Sa row 95.
Okay.
Tanggalin natin yan para hindi na niya i-print. Kasi pag linagyan natin ng parenthesis, di ba, i-print niya. Yan, kahit yung first 6 values na. Yan, okay? So okay tayo sa ano no sa P1V. Okay, so yan ang ginamit natin. Sige, pakiran mo ulit yung wag na yung dot P, hindi natin kailangan yan. Pakiran mo na yung 104, yung code chunk na yan.
Yes, sir.
79 pa rin. Why? Kanina ba pareho tayo, chart ng output?
Kanina, sir, nag-error. Sorry.
Sa kanina, yung unang-una natin? Nag-set.seed ka ba? Ano ka? Baka hindi mo na lang yung set.seed, yung sa ano? Baka kaya magkaiba tayo. So, backtrack na tayo ulit. So, 84, 80. Oh, iba eh. Iba yung mga result mo eh. Palagay ko, ano, magkaibang dataset yung inaano natin. Sige, akit ka pa. Akit ka, Char. Sige, go up. Go up. Simula dun sa, ano, sa pag-partition ng data. Okay. Sige. Okay. May suspicion ako na hindi mo na rin yung ano. Tanggalin mo na, Char, yung ano, tanggalin mo yung parenthesis ng ano, ng train. At saka ng validate. Tanggalin mo siya. Yung sa 39, yan. Okay, yan. Pati sa validate. Sige. Yan. Sige, i-run mo nga yung chunk na yan, yung 36. Okay, tapos i-view mo si PD. I-type mo na lang kahit sa console na lang. View PD. So, tingnan natin. Oops, yan na naman siya. Print, ano na lang, print PD. Kasi, pero although mukhang tama siya, print PD na lang. Small p, ah.
Ano pa kaiba ulit, sir, nung pag sa uppercase or lowercase?
Sorry.
Pag lowercase or uppercase.
Case sensitive kasi ang ano eh. Case sensitive si R. So pag kinapital P mo yun, hindi siya mag-run.
Okay. Pero yung pag-view, kailangan cap, sir?
Kailangan capital yan. Oo. Yung print small. Okay, ito, tama pareho siya. Yung 5th, tapos yung 14th. So okay na, tama na yung ano natin, pag-partition natin. Sige, balik ka dun sa ano. So meron na tayong train, ano? Meron na tayong train at saka validate. So sige nga, ilan mo ulit si 3 sandali. Si 3.1A, si 3.1 lang. Yung model lang, Chard. Yan. Okay, so may 3.1 na tayo na based dun sa set.seed. Okay, si 3.1b. Baba, sa row 62. Wait. Yung 1A mo kasi, yung ano, no, yung tatlo lang yung variables natin. Sige, alam mo yan, 3.1b. Okay, sige, punta na tayo sa ano natin, sa predict. 3.1. Sige. Okay, tapos ito yan, sige. 82. Ano, Chart, dapat ano, 3.1 lang kasi yung .1A mo, yung tatlong variables lang siya. Di ba, tinan mo yung sa taas mo. Tinan mo yung sa taas. Kaya ang ginawa kasi natin, yan o, yung 1A mo, tatlong variables lang eh. Para hindi tayo kamalito, sige, tanggalin mo muna yung ano, yung 3.1A mo, gawin mo muna dot. Madali naman kasi gawin na yung ano eh.
Ito, sir?
Yan, dot na lang. So, ibig sabihin lahat ng variables na, no? So, i-run mo yung row 53 na yan. Yung 53 lang.
Ay, sorry.
Sige. Okay na, sige. I-X mo na lang yung result. Okay, so meron na tayong 3.1A, ano? Baba ka na. Yan, sige, pwede mo
Yes,
nang
sir.
ilan yan. Yan, okay na. 93%
Okay,
na. So, yung kanina, yung 82% mo, kasi 3.1a sa'yo yun, yung
three
tatlo lang,
variables.
tatlong variables lang. Okay, so
Yes,
sabi ko nga kanina, di ba, pag the more variables, the more the predictive power. Di ba? Pero once again,
Yes, sir.
yung minsan sa complexity ng model, pag masyadong marami, and sa C3 kasi hindi natin tinitingnan yung yung significance ng variable. Binibigyan na sa atin yung output kagad sa decision tree. Unlike pag-regression, ibibigay sa atin yung yung kung significant ba yung variable yan or not. So that's
Okay.
one
Yes, sir.
difference. Okay, so pwede mo na i-run si 1B. Yung confusion.
Ay, sige, sir.
Sige, i-predict mo muna. Predict mo muna tapos i-run mo.
One B.
Baba ka. Ayan, yung nasa taas pa, chart. Taas.
Ito, sir.
Yan, oo. Sige, pwede mo dapat may predict muna sa taas pa.
Ito, sir, nirun ko na ito. Tama ba?
Yung
Ito.
table yan dapat
Yung
yung
1B. Ito, sir.
run mo na si 3. Yan, oo. Yan, si P1T. Okay, sige, okay na yan. So, baba ka na sa P1.
Ito, sir.
Yan, sige, i-run mo na yan. Yung buo na pwede. Yan, 84 ba? I think 92 yata yung lumabas sa amin. So, 1B.
1B, check ko yung 1B, sir. Baka hindi ko na.
Sige, check mo na lang
Yes, sir.
Sige.
Okay, sir.
Okay, thank you.
Thank you.
Share ulit ako ng screen Okay. Share screen. Alright. So, na-misclassify na natin yung nag-create na tayo ng confusion matrix. Okay, 92%. Yung unseen data, yung validate. Ang taas, guys. Very, ano yung model natin? Very good. Nakapag model na without using the data that it has not yet seen or observed. Okay. So may isa pang may ito, yung question ni Richard kanina, yan lang ba yung package na pwedeng gamitin? Hindi. Ito, R-part. So paki-install nyo muna, guys. Dalawang package na yan. Install that packages, you know what to do, guys. R-part at saka rpart.plot. And once you have installed it and then acquired and loaded it, paki-sabihin nyo sa akin para I'll continue discussion. Okay, ito dapat to be consistent, dapat that dito. When you're done installing
Yes, sir.
Ina, tapos na. So, Ina.
Pati ba yung rpart.plot?
Yes, oo. Both.
Hindi pa done yung dot.
Sige, we'll wait for you.
Okay na, sir.
Good. Okay, here we're going to use another package. I-load nyo na siya, library nyo na. We're going to use another package, rpart. Okay, it has its pros and cons then. Rpart is better as far as plotting is concerned. So let's create another object called 3.2 and then we're going to use the rpart. Tingnan mo natin, guys, for question mark rpart. Dito na sa package. Packages. rpart. Always a good idea. Good practice to rpart. ganun din siya, no? Recursive partitioning din siya. Okay, ibig sabihin recursive partitioning, umuulit-ulit, no? Okay, and then, so parang ano din siya, parang yung kanina, yung party package. Description file. Okay. So it says here, our part, authors, recursive partitioning for classification, regression, and survival trees. An implementation of most of the functionality of the 94-84 book by Bryman, Friedman, also, etc. So this was developed 2019. Okay, hindi natin na-compare kung ano yung date ng party package. But you can, of course, take a look at yung mga ano ito, my user guide and my vignettes and other documentation. Tapos ito yung mga ano nila. Ito yung mga functionalities. And then yung isa din, guys, doon si our part, no? Our part.plot. Okay, so let's run this. Tingnan natin. 3.2 print 3.2. So, okay, ano nangyari? NSP then ulit. NSP, let's remove that. Okay, so ano yung 3.2? It's a list of 14. Parang kanina yung 3.1 din. Okay. So it contains several objects, no? And then let's print 3.2 plot. Okay. So quite similar to yung sa party package. Okay. Medyo similar siya. Nagkakaiba lang siya sa printing, no? Ito. Let's look at our part.plot ng 3.2. Okay. So medyo I like the plots of our part a lot better than mas maayos siya. Although hindi ko na makita yung ano. If you can use a magnifying glass, no? Okay. Anyway, guys, parang ganun din siya, no? Ito yung classification tree niya. So ito yung mga terminal nodes na 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 yung nodes niya dito. I think may color coded din to, no? Yung brown 1, yung gray is 2, and the green is 3. Okay? So clear, guys, yung yung mas maganda yung art plot na na sa pag-plot ng ng decision tree. I like it better. Lalo na kung mas konti lang yung yung nodes, mas kitang-kita siya. Okay. Now, just as a practice, guys, para mapaliit ko lang yung mapaliit ko lang yung I'll just call it 3x. Sige. Copy ko na lang para hindi tayo nalito. Sige, ayusin ko muna to, guys. Ano yung muna to? So 3.2 and then extra is equal to 1. Pero mas maganda kasi, sige, let's do this, guys. Let's create this object. Open natin ito, Control-C, Control-V. I'll call it X. And then, i-regress lang natin yung first, yung parang yung kanina, LB plus, ano yan? Ano yung first two variables na? LB, AC, ano ba yung nakalagay din sa taas?
FM.
LB, AC,
LB,
FM.
AC, FM. Yes, sir.
Okay, let's do that. Just to illustrate to you guys, LB, AC, plus FM. Okay, just illustrate to you yung different na ano na yung different plots that can be generated. Kasi yung malaki kanina hindi natin nakikita, no? So let's just assume that we're just we're creating the tree based on these three variables using the train data. So if we print this, print natin at saka run na. Okay. So ito yung print. Okay.
Hindi ba 2x din dapat? Sir?
Ay, oo, sorry, tama. Thank you, Ina.
Okay.
Mali ako. You're correct. Otherwise, pareho pa rin yung print na kanina. Okay. Kaya pa rin taka ko, bakit ang dami pa rin? Yan. Okay. You can see this, guys. Diba? Mas ano si our part, no? I like the way it's printed. Mas maayos siya. It's a lot better than yung kanina sa party package. So for example, yan, color-coded guys. So brown 1, gray 2. Okay, so ito sinasabi na if AC is greater than a certain value, okay, pag yes, dito na kagad siya. Ano kagad yun? Yung normal. No? At pag no, anong gagawin? Titinan si LB. No? If LB is less than 137, okay, go here, titinan si FM. If FM is less than 0.2, if it's yes, yung yes nasa left, no? Normal yon. If it's no, then pathologic siya. Okay, so that's how you read this model. Okay. And then may may variations to, no? So dito, so let me just plot this yung X. Yung X lang gamitin natin kasi pwede natin idagdag yung extra is equal to 1. Pag extra is equal to 1, idadagdag yung sample sizes. No? Okay, ano na notice natin dito? Okay. Nilagay niya dito guys yung what does this mean? 1348226. So dito magsisimula, di ba? Si 1, 1348. Tapos si 2, 226, 144. Total niya yung 17 something. So we look at AC first. If it's less than this value, pupunta sa dito, di ba? Yan. If it's less than this value, yes, then dito siya. And dito ang pupunta sa 1, 934, tapos 33, tapos 21. Okay, ibig sabihin, yung 1, ang 934 yung tama, 33 yung na-predict as 2, tapos 21 na-predict as 3. Okay, so binibigay niya yung sample sizes. Okay, and then if we go to, ano naman itong number 2, so nagbigay na ako ng distinction dito. Yung proportion. The proportion, so, yan. Ang linagay niya dito, okay, is, so dito, 1348 out of 1718 yung total na 1. Yung proportion ang linalagay niya. So 934 out of 988. And then dito sa ano na to, dito sa path na to, (414). Ano ba yan? 414 out of 730. Okay, tapos okay. Kasi itong total na 1718, 988 yung pumunta dito. Tapos 730 yung pumunta sa no. Tapos yung 730 na to na split into 416 and 314, etc. So makikita natin dito yung splitting niya and the proportion. The proportion, okay, so 934 out of 988 dun sa 1. So, ang mini-measure niya dito yung tamang observation ba? Okay. Mukhang yung tamang observation. Pero guys, kaya na natin i-decipher ko ang ibig sabihin ng ratio na yan. And then last, the proportion that belongs to the group. Number 3, that doesn't belong to the group. Yung opposite niya. Doesn't belong to the group. So, okay, yung opposite niya kanina guys. No? So 54 out of 988 did not belong to group 1. Yung opposite kanina ng ng number 2. And number 3, proportion of NSP. Okay, yan. Ito yung probabilities natin kanina. Okay, so in terms of guys, in terms of presentation ng decision tree plot, I prefer CR part. No? Kasi mas malinis yung niya, yung data niya. Okay, so let's take a look at this. Predict natin si 3.2, tingnan natin. No? So predict, let's create this object P2, predict 3.2, type is equal to class, and then yung head lang, print natin. Kasi masyadong mahaba yan. Head lang ng P2. Pag-class kasi guys, di ba? 1, 2, 3 din yan. Di ba? Yan. Okay, so observation 1. So 2, 1, 1, 1, 3. Isama natin si isama natin si head ni head of, ano ba ginamit natin dito? Sa model natin. Train. So compare natin yung train data natin. Train $NSP. Okay, so let's run this. Okay, ang actual natin 21133. Ang prediction natin dito 21133. So yung first six tama siya, no? Tama lahat si 3.2 using the R part. Okay, and then confusion matrix natin. Tanggalin natin si P dito. Predicted P2, actual. Okay, print natin si tab. Dapat isama na natin si. Okay, sinetrate ko pa dito. Right here. Natin yung tamang tab 2 ba? So tab 2. Yeah, tab 2. Okay, 93.77. So halos pareho lang ni party. Okay, not so much difference. No? Not so much difference. And then if we use the validate, predict 3.2 new data natin is validate type is equal to class validate to. Okay, then compare natin si head. Not print lahat at saka si head ni validate si NSP. So let's run this. Okay, let's see. 111331, 111332. So mali lang dito sa sa sixth observation. So confusion matrix. Okay, sama-sama na natin. Okay, walang F to. No F. Okay, tab TV. Okay. Alright, so this okay. Right, 90%, no? 90%. Well, not really that far. Kanina kasi 92 yung natin yung sa party package. Ito naman 90% yung yung correct prediction using the hard part package. Okay, any questions so far, guys? Clear ba?
Yes, sir.
Okay. So let's do this, no? Sige, mag-start tayo ng multinomial na regression, multinomial logistic regression. Wala akong wala akong nasulat. Sabi ko, ano na lang natin, tayo na lang gumawa mismo. Mas maganda from scratch, no? Ang gagamitin natin na data si si Carjo. No? So let's open tayo ng new markdown. New markdown, okay? So let's call it a multinomial logistic regression using Carjo data. Okay. So, play tayo ng panibago. Close muna ito mga natin. Okay. Okay, so install muna tayo ng package, i-load muna natin mga packages natin. Ang mga usual na kailangan natin, library. So let's see, ggplot2, pass natin. Pwede namang combine, ggplot2, and then dplyr. Actually, si tidyverse, ang ginagawa siya. Tidyverse, ano ito ba? Site. Kailangan natin ng ano. Okay. So, load muna natin to guys sa mga available na yung mga na-load natin dati. Okay. Must be of length 1. Wait. Ito pwedeng concatenate siya. Okay, sige. Ayaw guys, no? Ayaw niya magpa-concatenate. So, just have to load this one at a time. Okay. Okay. All right. Then, ano pa ba kailangan natin? Na-install, guys, paki-install nga to. If you haven't installed this, kasi hindi pa natin yata nagamit ito dati. Si Caret, no? The Caret package, which is a very powerful package for classification and regression trees. And then, meron pang, sa multinomial, gamitin natin si MNet. Okay, and then isa pang library, si E10721. Okay, most probably guys, hindi nyo pa na-load to, no? So install packages ito, and then i-load nyo. I'll give you a few minutes to install those packages. Ready guys? Inform na ako.
Yes, sir. Yes, sir.
Thank you, Char. Let's wait for email. Okay, good. All right. So before we even go to multinomial, tingnan muna natin yung mga bagong packages natin. Si ggplot2, alam natin yan. Dplyr. Tidyverse, guys, is a family of packages. No? So if you run, separate ko yung pag-run ng library ng library tidyverse. Parang universe to universe, tidyverse siya. Okay? Siya. Package siya. Siguro pag install that packages, no? It will show you, or i-search natin sa internet, for example, ano yung mga laman ni Tidyverse. It consists of several packages. No? Kunyari, andun si ggplot2, andun si dplyr. Okay? So, but let's take a look at Caret. Kasi mamimit ulit natin ito si Caret. No? Let's take a look at Caret package. Here, wala. Go here to Caret. Yeah, okay. Classification and regression training. Description file. Marami naman to, guys. Okay, ito yung description. Authors. Marami authors. Then description, miscellaneous functions for training and plotting classification and regression models. Okay, and dami authors kasi pala, no? Pero ang alam ko si Max Kuhn kasi yung pinaka-main, no? Yung iba contributors lang. Si Jedwing, Steve Weston, these are contributors. Si Max Kuhn siya yung author, siya yung creator. The rest are contributors. So, balik ako ng konti. It pays guys to ilan to? Version 6.0-90. When was this? Ilan yung insertion ng ano na to? Nalagay ba siya ng date? Walang date. I'm looking at the date this was developed. Relatively bago to. Okay, hindi nakalagay. So, user guide, package, vignettes, and other documentations, you can access that. Guys, tignan nyo ha. Tignan nyo yung dami ng ano nito. Yung dami ng functionalities. Okay? So, sa machine learning, gamit na gamit itong yung Caret package na to. Let's see, mayroon ba ditong confusion matrix? Okay, so dito, meron, yan guys. So, confusion matrix. Okay. Yung ginagawa natin kanina na nag-create tayo ng confusion matrix, pwede ito yung gamitin natin. Confusion matrix, so data, reference, and then may mga parameters pang kailangan, and then may sample ba siya dito? Example, no? Example. You can run this example, guys. Nag-create siya ng object na normal at saka abnormal, tapos truth, may repetition siya, times is equal to 86 at saka 258 times, etc. So you can follow along with this, guys. And then tingnan nyo guys yung confusion matrix. No? We will not do that anymore, but I strongly urge you to really, when you're learning a particular package, tingnan nyo guys, kailangan binabasa natin. Another one guys is NNet, neural networks. Okay, ito isa din itong gamit na gamit guys sa machine learning. So wala pa siya dito. Lagyan natin dito NNet. NNet. Yan. NNet. Free forward neural networks and multinomial. Guys. Multinomial, log normal, log linear model. So ginagamit to guys, yung neural net na to. Especially good for neural networks. Description. Okay, sabi. Description, software for feed-forward neural networks with a single hidden layer for multinomial log linear models. So this is good for multinomial modeling. Okay, meron ibang ano guys, meron pa ibang packages on multinomial logical regression. This is what we're using, but there are others. May isang function dito yung gagamitin natin. Ito si multinom. Multinom. This is what we're going to use. Multinom. Ito yung parang LM. A formula expression for regression models of the form response tilde predictors. The response should be a factor of a matrix of k columns, which will be interpreted as counts for each of the k classes. A log linear model is treated with coefficient 0 for the first class. Okay, so ayun guys, itong multinom na to, naalala yung log odds ratio, parang ganun din siya. Tapos, kasi, kunyari, tatlo yung factors, ang mangyayari niyan, gagawing benchmark ng isa with coefficient 0 for the first class. So yung class number 1, yung group number 1, gagawing 0 siya, the rest will be benchmark against the ano. Parang ano siya guys, no? Parang factor siya. An offset can be included, okay, etc. Alright. So gagamitin natin ito. Tapos yung isa, itong question, ito na lang sa package. Ito na lang, E1071. So what is this package all about? 1071. Okay. Miscellaneous function, probability theory from formally capital E, 1071. Ngayon ginawa ng ano. If I'm not mistaken, Hong Kong University ba ito? Or Stanford ba? Let's check. Miscellaneous functions of the Department of Statistics Probability Theory Group. Okay, sinabi ba dito kung saan university siya? Description. Okay. TU Wing, yung author. Kailan yung update nito? Okay. Ano yung mga functionalities niya? Okay. Ang latest na ano? September 16, 2021. So, pero yung capital E1071, medyo matagal na yun. So, in-update lang siya. Built under R 4.0.5. Okay? Alright. So, isang ano yung mga functionalities niya? Sa plots, meron. Okay. Support vector machines, gagamitin natin ito. Itong support vector machines. Not now, but in the next sessions. May sigmoid siya. Sigmoid, tapos may ROC ba siya? I think may ROC siya. Meron ba siyang ROC? Meron ba siyang rocks? Wala yata. Wala siyang rocks. Saan ba kanyang rocks? I think sa NNet, no? Sa NNet. Rocks. Okay. Anyway, sige. Let's start. Let's first load yung ano natin. Load natin data natin, guys. Gagamitin ulit natin let me see kung kasi hindi ko pa di ba may cardio na tayo? Let's see view cardio. Okay. So ito yung cardio natin. Gagamitin natin si cardio. So let's see the structure of cardio. Glimpse lang, glimpse. Para makita natin kung if we're going to use it in another markdown file, will the class of the variables be okay? Ano pa rin si NSP, no? Factor pa rin. Good. So ito guys, gagamitin natin si cardio, but this time hindi nauna kasi yung nangyari sa atin, nauna yung inuna ko kasi yung classification tree. Kasi hindi pa natin nagagawa yun. Ito multinomial, quite similar siya dun sa GLM natin, yung generalized linear model natin. Ito talagang purely regression. Okay. So, let's see how far we can get, guys. So, andyan yung cardio data natin, ano? Alright. So, tingnan muna natin guys kung pag multinomial ba, multinomial. Kasi sa binomial, di ba, tinitingnan natin doon yung log odds ratio, di ba? Sa multinomial, I think I have to on ko na yung digital pen ko guys para hindi na lang susulat. On ko lang yung digital pen. Let me just discuss how we set the equation sa multinomial. Mas maganda kung mag-set muna tayo ng yung theory behind. No? Okay. Right. So I'm going to use Excel na lang. Para pag na-set na natin yung model natin guys, alam natin kung paano i-interpret. Kasi madali yung modeling eh. Mag-multinom lang tayo tapos lalabas na yung output. Pero how do we interpret it? So to interpret it guys, we have to understand yung nature ng yung model mismo, which is quite similar to logistic regression, binomial logistic. Okay, so let's just use this blank. And then start thinking now. Okay. So di ba ang din, just like any regression model, di ba in general y is equal to beta null plus beta 1 x1 plus beta 2 x2 plus dot plus beta sub n x sub n. Okay, so this is how we generate our regression model. Now, sabi dati, diniscuss natin, di ba yung log odds ratio? Okay, sa multinomial medyo iba. Kasi depende dun sa natin sa level ng factors natin. So let's assume for this, for our discussion, yung natin, yung dependent variable natin is tatlong levels, no? Ano yung levels na yun? You have N, you have S, and you have P. Okay, how do we now generate a model for this? Pag multinomial guys, sabi nga dun sa multinom na function, diba? Ang mangyayari dyan, yung isa gagawing benchmark. So whether it's N or S or P, no? Bahala tayo dun kung sino gagawin natin benchmark. Tapos ang lalabas na result will be, kung gawin natin N yung benchmark, ang lalabas na result S at saka P. So dalawang result ang lalabas kasi tatlo yung factors natin. And how do we interpret it? We interpret the coefficients as the log odds of that particular variable relative to the log odds of S, for example, in relation to n. Okay? So ganun lagi yung pag-interpret. So sige, gawin na natin. No? So if we have three response variables, dalawa yung equation na lalabas dyan. Kasi gagawin benchmark si n. So magkakaroon isang equation kay s, isang equation kay p. So let's start with, let's assume that n is our benchmark. Okay, so we have y1 is equal to log. Okay, ganun din, no? Log, this time it's not p over 1 minus p. It's p sub 2 relative to p sub 1. Okay, so that's our y1. And then our y2 will be equal to log of p sub 3 divided by p sub 1. Okay, ganun yung ano niya, ganun yung relationship niya. So when you interpret the output, yung coefficients natin, it's always the log odds ratio of yung S, kasi yung S yung P2 natin, in relation to N. Okay? Alright, so once again guys, we can simplify this. Okay, we can simplify this as, paano natin matatanggal ng log? So gagawin natin, we'll raise it exponentiate it maging e to the y1, okay, is equal to, so pag in-exponentiate natin ito, mawawala na si ano. So that's p2 over p1. Diba? Okay, from here we know that p1 should be equal to p2 is equal to P1 times E to the Y1. Okay? So, ano lang ating relationship na. Now, ito naman si Y2. Y2 will be, kunin natin exponential E to the Y2. Bakit Y1 at saka Y2? Kasi, guys, tatlo yung levels natin. Okay, therefore, we expect to have two equations. Parang k minus 1 din, k minus 1 equations. Kung 4 levels to, dapat tatlo equations natin. Y1, Y2, Y3. Okay? So, simplify natin to. This would be equal to P3 over P2. Or, dito ang gagamitin natin relationship na P3 is simply equal to P1 dapat. No? Ang benchmark natin is P1. P1 times E to the Y over 2. Yeah. Okay. So, continue natin. Knowing these relationships, what do we have now? So let's add the two. If we add natin si P2 over P1 plus P3 over P1 is equal to E to the Y1 plus E to the Y2. Inad ko lang silang dalawa. P2 over P1 plus P3 over P1 is equal to E to E. And then combine natin to, ito ko lang isusulat. Combine natin is equal to over P1 is equal to P2 plus P3. So E to the Y1 plus E to the Y2. Okay, sorry for this mathematical discussion. Okay, now we know, alam natin guys kasi yung total probabilities yan, no. Yung probability ng being normal plus probability ng being suspect plus the probability of being pathologic should be equal to 1. 100% dapat. Kasi tatlo lang naman yung ano natin, yung mga possible values. No? So if we sum up all of these probabilities, it should be 1. So we know guys that P2 plus P3, okay, P2 plus P3 is simply equal to 1 minus P1, diba? Right? P2 plus P3, palitan natin to we replace this by 1 minus P1 over P1. So now everything is expressed in terms of P1. Okay, so this is now easy to manipulate. Yeah. Okay, so the expression natin sila lahat in terms of P1. Therefore, we can now compute for P1. Okay, so distribute natin 1 over P1 minus 1. No? Distribute lang natin sa P1 is equal to e to the y plus P1 plus e to the y 2. So, simplifying this very quickly, 1 over P1 is equal to 1 plus e to the y1 plus e to the y2. Therefore, P1 is equal to over 1 plus e to the y1 plus e to the y2, 1. No? Okay, so that's P1. Okay, since alam na natin si P1 guys, makukuha na rin natin si P2. What's P2? P2 is simply equal to, based on the relationship above, P2 is equal to P1 times e to the y minus 1 sa taas. So therefore, P2 is simply equal to P1, which is this one, 1 over 1 plus e to the y1 plus e to the y2 times e to the y1. E to the y1. Yeah, ganun lang. So that's now P2. And then your P3 will now be e to the y2 times P1. So dating ko na lang, P3 is equal to e to the y2 over 1 plus e to the y1 plus e to the y2. Okay. So that's how, this is how the multinomial logistic regression is done. Okay. So log adds din to. The log adds ratio of P2 in comparison with P1. The log adds ratio of P3 in comparison with P1. So that's how it is read. Okay, and of course, guys, sabi natin katulad ng dati, hindi natin binabasa yung log adds kasi mahirap i-interpret yan. So we transform it into probabilities. Okay? Okay, so clear so far, guys? Clear ba yung derivation natin ng probability ng P1, P2, at saka P3. So paano kinocompute si P1, guys? Okay. Model muna, di ba? Model, tapos ano gagawin natin? Whatever the model is, isa-substitute natin sa mga values so that we're able to get to compute for your y, no? Y1 at saka y2. Okay, pag nasolve na natin si y1 at saka si y2 for a specific y1 at saka si y2, and then we can now compute for a particular observation, we can now compute for probability na normal for that specific observation. Remember guys, if we have 1,700 observations for the training data set, so meron tayong 1,700 na values for P1, P2, and P3. Kasi bawat observation, meron siyang corresponding na a probability for normal, probability for S, and probability for P, suspect, or probability for pathology. Okay, so let's now apply this. Kasi ito lang naman yung nangyayari, no? So that at least armed tayo, alam natin, ganun pala yung ginagawa ng kami yan na multinomial logistic regression. Kasi pag alam natin guys, it's easier not to panic. Kasi pag kunyari hindi mo alam, ano ba nangyayari dito? Parang ang hirap ngayon, may hesitation tayo na i-interpret kasi we don't know what's happening behind the scenes. No? Pero ito, alam natin, ganyan lang yung pag-compute niyan. So once we're able to do the model, pag na-model natin, then we can now compute for the probabilities. Okay, sige, let's continue. Okay. So na-define natin si P1, which is equal to 1 over 1 plus e to the y1 plus 1 plus e to the y2. And then P2 is equal to y1 over 1 plus e to the y1 plus e to the y2. And then P3 is equal to e to the y2. The same denominator. Okay. All right. Now we have to define, guys, kung ano yung gusto nating ano gusto nating ano ba yung gusto nating benchmark. So sabi nga natin si R, hahanapin niya yung alphabetically na ano na mauuna, which is in our case kasi naka-ano na siya yung data natin, si NSP naka 1, 2, 3 na siya. So mauuna talaga si 1. No? Okay, but if you want, guys, if you want to change it, pwede natin gawin. So cardio, let's go dito to name the benchmark. Okay, kung gusto natin, guys, baguhin or just to know how we change the benchmark or how we name the benchmark, and not to use the algorithm of R where it uses the first one that appears alphabetical or numerical. Kasi what if we want to use si pathologic as the benchmark? So how do we do that? So, ang gagawin natin, cardio, yung ano natin, cardio NSP, okay? Okay, alt minus. So we're going to use from the stats package. So may stats package, may function na re-level. Yeah. Re-level. The levels of a factor are reordered. Yun. Okay? So ito yung ginagamit, guys, kung gusto natin i-reorder yung ano natin, yung factors. So that the level specified by ref is first and the others are moved down. Okay? So re-level natin, sino i-re-level natin? Si cardio NSP. Si cardio NSP. And then yung reference natin, okay, gawin natin reference is equal to, si 1 na lang, guys, para it's just, we're just discussing here how to change the reference. The benchmark. Pwede nyo gawin 2, pwede nyo gawin 3. For our purposes, let's just use 1 as our reference. Okay, guys? Okay ba?
Nire-replicate ko ba, sir, yung code?
Sorry. Ano, no?
Nire-replicate ko lang, sir.
Okay. Sige.
Pero clear naman.
Sige, okay. Sige, gawin nyo guys. Gawin nyo. From scratch tayo, no? Wala tayong notes dito, no? Medyo ano ko naman medyo madali naman yung syntax ng multinomial. Parang binomial lang naman siya. Once we have run this, once we have run that, we can now split na natin yung data natin, partition data natin. Okay, then we use again set.c. Ibigay naman natin number, no? Ibigay naman natin na 4, 5, 6, 7. Kunyari. Any number naman yan. 4, 5, 6, 7. And as usual, guys, let's create an object called index. An object called in. Tapos gagamitin natin si sample. And then we will split it into 2. Tapos ilan yung split into 2? Yung number of rows natin ni and row di cardio. And row di cardio. Tapos replace natin is equal to true. And then yung probability natin, place is equal to true, and then probability is C. Gawin natin, ano ba ito? Para pareho kanina, 0.8 at saka 0.2. Okay, siguro guys, magandang gawin natin. 1, 2. Ipareho na lang natin set.c, no? 1, 2, 3, 4. Para in case pwede natin i-compare kung sino mas maganda kung sa confusion matrix sino mas mataas na ano na kasi parehong date tayo kanina, di ba? So meron tayo kanina yung accuracy rate, no? 93% yung sa 3 dot ano natin, 3.1a yata yun, ano? So ito naman regression yung gagamitin natin. Okay? And then of course mag-train tayo dito. Train so train natin will be yung ano natin yung cardio data. Cardio. Ano natin subset natin. Gamitin natin si in yung lahat ng 1 and then all the columns, okay? And then let's use the test na lang. Test. Okay. Cardio also. Okay. In is equal to 2. Pause for a while, guys. Okay. Kindly write the code. Once you're done, guys, pakisabi-sabi na. Pinareho natin set that sheet para yung parehong sample na mag-generate natin. So that we can compare kung pareho yung kung how a multinomial regression model will compare dun sa CART, no? Ilan yung accuracy.
May error lang, sir.
Which one?
Nalagay sa akin unused argument yung int equal
Sorry?
to 1.
Sorry.
Ano, sir? Ito here.
Stop
Ilagay ko
share.
sa chat.
Sige.
Sa chat ko, sir.
Iran ko rin itong error in, saan ako nagkamali?
Ayan, sir. Same.
Same. Bakit man? Karawanan natin ito kanina. Diba? Mali ba ako sa code ko? Okay. I-compare natin guys sa natin. Sa ginawa natin. Ito lang naman yun, diba? Ay, sorry. Sensitive pala si R sa okay guys, my apologies. Dapat double equal yan. Okay. Dalawang equal sa yan. Otherwise, mag-error talaga. Okay. Tama na.
Okay na, sir.
Okay. Alright, sorry for this guys. Take note, equal dyan. Pag nagsasubset na tayo, double equal dapat yan. Okay, so we can now run our model multinomial model using gagamitin natin guys si mnet, no? Mnet, merong function si mnet na multinomial. So ito regression model to, yung kanina kasi cartoon no? Decision to yung ginamit natin. Right? So let's call this M1 na lang. No? M1 for model 1. And then we're going to use yung lalagay ko saan package siya, yung namespace niya. Mnet, and then kita nyo to, no? Mnet, and then makikita natin yung mga functionalities ng mnet na. Okay? So we're going to use the multinomial. Tapos yan, may information dito. Formula data, may weight, subset, etc. Fits multinomial log linear models via neural networks. Okay, so here, mnet, and then multinom. Okay, and then we have our NSP tilde dot natin, sabihin lahat, comma, data, so ito yung plain natin. Plain data natin. And then summary, and then Okay? So, minamodel natin si multinomial. Okay. Alright. So, anong nangyari dito guys, nag-iterate siya, no? Iteration 1. And notice guys, na 371, residual error ba siya? Ang nangyari sa kanya, nag-model until such time residual variance is 743. Okay, I'm not sure kung ano yung 371 na to, no? Iteration 80, 90, 100. And then it stopped at 100 iterations. Sinanap niya yung lowest na value nito. I'm not so sure kung ano yung 371. Kasi tinitin ako sa AIC at saka sa residual variance, hindi naman siya yun. Okay? But we know this is something that's where the lower the value, the better. Kaya 371 yung final stop niya. And then the formula is NSP regress on all our predictors. Okay. So notice guys, ito yung output Lakyan ko ulit ko dito. Yan. Napansin nyo guys, merong 2 at saka 3. So medyo kakaiba siya dun sa output ng output ng regression natin, no? Ng LM or even the GLM, yung family ng binomial. Okay, and how do we interpret this? How do we interpret this? Again, this is interpreted as log odds, no? Log odds, and then kunyari itong AC. Anong interpretation nito? For every 1 unit increase in AC, there's a corresponding 978 what? There's a corresponding what, guys? There's a corresponding 978 log odds, diba? Decrease in log odds ratio, but decrease in log odds of being suspect as compared to being normal. Kuha nyo guys. You see how it's interpreted? It's interpreted as the log odds ratio of being suspect as compared to normal. Bakit suspect as compared to normal? Kasi number 2 to, and you will always compare it in relation to number 1, si normal. Ganun din dito si AC dito si 86, negative 86. So it means that there's, for every 1 unit increase in AC, there's a corresponding 86.87 log odds, decrease in log odds, no? Okay, of being
Pathologic, sir.
pathologic as compared to
Normal.
Yun ang interpretation niya, no? So, ang hirap talaga sa interpretation, kaya we don't look at the log odds, we look at the probabilities. Kasi ang gusto natin malaman kung ano yung probability na magiging normal siya, probability na magiging suspect, or probability na magiging pathologic based on these variables. Okay, tapos hindi lang yung coefficients ang binibigay, pati yung standard errors. Okay? So dito hindi binibigay sa atin yung z-stat or yung t-stat, hindi binibigay eh. Kasi sa regression binibigay yung coefficient, binibigay yung standard error, binibigay yung t-stat, binibigay yung t. Eh dito hindi. So kailangan ma-compute natin yun, no? We will be computing for just for exercise, no? Just to understand what's happening here. So i-compute na natin guys yung z value. If we recall nyo from stat, no? If you know the coefficients and you know the standard error, you can compute for either the z value or the t value. Sige, lagyan natin dito. tayo ng panibagong, no? So let's compute for compute. Natin yung z values. And then after we compute the z values, i-compute natin si ano? Si p value. Okay. So just for ano, di ba ang si ano guys, si M1, anong klase object ba si M1? Regression output to, di ba? M1. M1 list of 26. Yan. So n units and connection yata to, decay, entropy, maraming si multinomial. But what's important for us is, okay, so tingnan muna natin names, ano ba yung naman ng mga yan? Yan. Okay, so we can get the coefficients. Ito to. Kasi na yung coefficients. Asa na siya? N units and with coefficients. Bakit meron yan? Tingnan nga natin. Let me check.
Nakatakas yung weight doon?
Ha? Names too. Names. Bakit wala siya? M1. C. O. C. O. Kasi dapat ito guys, dapat meron ito. Yung mga coefficients ng mga variables natin. Why is it none here? Tama ba yung name ko? M1? Ito, multinomial. Let me try it another way. Kung summary ng M1 and then yun. Oh, bakit wala din siya? Weird guys, ha? Weird. Okay. So, na-generate ko naman, no, guys. Itong kailangan natin kasi we need to divide yung coefficients by the standard errors. Okay, bakit kaya hindi siya naka-name din sa ano? Wala yung names ng coefficients. Pero pag generate mo naman, summary ng M1 and then coefficients. We can try that a while ago. M1 coefficients. Wala, not. No? M1 is supposed to be the regression output. Okay, so tanggalin ko na lang tayo. Okay, so let's see. So kailangan natin to, let's call it Z minus summary ng coefficients, control C, control V, and then we will have to divide that by summary, control V ulit, summary ng M1 ulit, but this time, ang pang-divide natin is, ano guys, yung standard errors. Okay? So basic yan sa stat, di ba? Basic dun sa ano, yung t-value sa regression output nyo, meron kayong coefficients, and then meron tayong standard error. No? Yung t-value, makikita natin na nagiging basis ng p-value is computed by the coefficient divided by the standard errors. Okay? So, sige, i-run natin to. Isa pa, tingnan natin kahit yung head ng Z. Run natin. That's the coefficients divided by the standard errors. Ayaw. Numeric zero. Gawin ko ito. So, i-run muna natin itong Z. So, let me see Z. Empty numeric. Okay. Empty numeric. Sige, anyway. Isa hindi na pinapakita. So, let's compute now for the p-value. P-value. Okay, gamitin natin itong si Z. Kunin natin yung probability is P norm ang gagamitin natin. Okay, are you able to follow? Yung P norm, yung ma-minus natin, sorry 100% minus yung P norm to give us the area under the curve. P norm ng ang Z kasi pwedeng maging negative, so dapat kunin natin absolute value ng Z. Okay. So tapos ang mean niya 0 kasi standard to 1. And then since this is then close natin. So since this is both tails, so times 2 tail to, so times 2. Okay, tinan ko kung medyo guys nag-ano ko, ano ko dito, no? Parang stock knowledge ang stock. Okay. So let's see. P-value. Ayaw. Then minus P1 okay. Sige. Pag ano guys, babalikan natin to. Hindi nag-generate yung Z value. Dapat kasi yung summary, yung coefficients, meron naman to. Tapos, ilan ko nga ito sa mga. Okay, let's see. This should work. Ano ba name dito na coefficients, at baka nagkamit ako sa pang-compute na standard errors. Standard error ba? Standard errors. So hindi. Kaya pala hindi nag-generate. STD. Hindi rin. Ito, dati guys, nagawa ko nito. Sorry guys, medyo M1. Okay. Details. Isang value lang yun. Ayan, guys. Sige, leave muna natin to guys, no? So I don't want to be bogged down by this. I was just actually pinapakita ko lang sa inyo na yung mga measures na to, it can easily be computed, no, using R. So since hindi natin ma-compute, okay, pero pwede natin i-predict na lang. Sige. So let's use thread 1, predict 1 natin, parang dati. No? So let's use the predict. Ito, sigurado naman papasok ito. No? Predict function, ang model natin M1. Okay, and then we're using the train data set. And then type natin is equal to class or response, pareho lang, or head natin thread 1, and then tail natin head, and then let's use the train, and then MSP. Okay, so ang ginagawa natin ngayon, guys, yung M1 natin, M1 model natin, pre-predict natin yung class na, which means 1, 1, or 2, or 3 yan, or another way to name this is response, kasi isa naman type is equal to probability, di ba? Or you can just ignore this kasi ang default niya, ang iaano niya sa atin yung class. So let's run this and see, compare yung mga yan. So ito si predicted value natin, 211133. Ito naman 211133. So at least for the first 6 values tama yung prediction, no? As compared to the actual. Gawin natin first 10. Comma 10. Okay, run again. Okay, 21113333. Dito lang nagkamali, no? Ito yung predicted 1, pero ang actual na 3. Okay. Okay, clear so far, guys? Pause muna ako.
Hello, sir.
Clear ba so far?
Yes, sir. Nasundan naman yung flow. Pero okay lang ba, sir, bumalik dun sa
Saan?
yung
Dito?
code for the model.
Okay, sige, sure.
Yung subsequent, sir, na sundan ko naman yung...
Ito, babalikan na lang natin to, guys, kasi nag-error ako dito, no? Pero tama yung formula na to. Hindi ko lang alam kung paano ko makukuha yung standard errors kasi it does not appear dun sa pag nag-names tayo, hindi nag-appear si si standard error. So I have to check, guys, kung how we can access yung z value. Kasi from the z value, gusto ko sana ipakita na yung probability will be the same as yung probability dito, no? Type is equal to probability. It will be the same. I wanted to show you that it's really easy to generate yung probability values niyan. Okay, ito Charles?
Yes, sir. Yes, bro.
So we're creating this object M1. Ginagamit natin si neural net.
Okay, sir.
Okay.
Okay.
Then, pagkatapos nun, di ba, in-interpret natin to. So always in relation, log adds in relation to, as far as the number 2 is concerned, relative to, in comparison with number 1, or number 3 in comparison with number 2. As this one, it didn't work, na may problem, na nag-null siya, hindi siya mag-generate. I'll have to check that. And then predict natin, guys, compare natin yung first 10 values ng predictions natin using the model M1, using MNet, yung multinomial. And then, ang medyo may misclassification lang siya dito. Okay. Then, guys, di ba, you know how to do the okay. Copy na lang natin dito, no? Para mas mabilis natin the type. Okay, we can use this, yung usual natin na na ginagawa. No? Control C. Baguhin na lang natin yung okay, let's call this tab 1. Tab 1 natin, table. Predicted natin is, ginamit natin to si pred 1. Pred 1. actual natin is train. We're first looking at the train data set. Okay. Print natin si tab 1. Tab 1. And then compare natin sum diagonal ng tab 1. Control C. Control F. Okay, so let's run this. Okay, all right, 90.68. So compared to the party package kanina, kaya yung R part, medyo mas mababa yung yung accuracy nitong natin, itong MNet, no? Using yung multinomial natin na model. But not so far behind. And then we can check. We can check, guys, kung ang gamitin natin this time is so copy ko itong Control C. Dito using yung test data natin. Control D. Okay. So prediction 1 for the test data, no? Yun na lang gamitin ko. So dito test data. So this one should be with a T. Okay. Tab, natin itong tab 1, 2, 1T, spread 1T for the test data to. 1T. Not to my T. Okay, so we're running this time for the test data. Run natin to. So sa test data, yung first 10, 1, 2, 1, 1, 1, 3, 1. So medyo may mga malaki errors dito. Marami errors dito. No? Nung ginagamit na natin siya for the test data. 1, 1, 1, ito 3, 3, 3, yung actual. No? So mukhang malaki yung malaking misclassified dito for using M1, no? For the test data set. Sige, let's see this. Tab 1 table predicted is equal to pred 1T. Sorry, test pala to. Mag-error siya, guys, kasi ito 300 plus 400 observations lang. Yung train 1,700 observations. So talaga mag-error siya. Hindi magkakaroon ng matching ng sample size. No? Okay, I think this is okay. There. Alright, so medyo mas mababa siya, 88%. Pero nung una kasi, di ba? Ang daming errors siya. No? Pero still 88% siya, din siya. As compared to 90%. Pero compared dun sa decision tree kanina, mas mataas yung decision tree. Okay, sige guys, let's just end in this. May ipapakita lang sa inyong ibang so there's another way, guys, to generate your confusion matrix. Natin, ha? Okay, question mark, confusion, ito, matrix. No? Confusion matrix. Mas magandang gamitin ito, guys, kasi mas maraming pwedeng i-generate na results. So far, guys, yung confusion matrix natin, ang ginagamit natin is just creating a table to compare the predicted value and the actual value. And then print natin yan, di ba? Tapos kinukuha na lang natin yung sum ng mga diagonals divided by the sum of the total. Now, there is another function which is more powerful kasi mas marami siyang generate na output. And it's making use of the caret na confusion matrix. So, gawin natin, okay? So, I'm going to use the current package. And then, ito na yung confusion. CO, ayan, confusion matrix, no? Confusion matrix. Okay, ang kailangan natin dito is, ano yung object muna natin? Our object is, let's use yung predicted value natin. Okay, pred 1 muna, no? Pred 1 yung kanina sa train data set natin. And then, comma, train. Compare natin siya sa train, NSP. Yung isa naman, pred 2 at saka yung test NSP. Let's run this. Okay, take a look at this, guys. Ayan. Di ba ang daming ang daming, pwede pa natin i-expand yung output na yan. Meron pa mga generate dyan. So if you take a look at this, yung confusion matrix natin to, pareho naman sa kanina yan. 1, 2, 9, 1, 60, and 6. 1, 2, 9, 1. Yan, yung 1 natin. 6 and 6. It's exactly the same. Pero ito, isang line lang, yung confusion matrix natin. So we just identify kung ano yung predicted value at saka ano yung actual value. Okay, so it's exactly the same. Kaso, may mga binibigay sa atin dito. Number 1, accuracy. No? Accuracy rate, 90.69, pareho lang sa kanina yan. Okay, 90.69. And then meron pa dito yung meron pa dito yung 95% confidence interval. Ano ibig sabihin nito? Kasi kanina 'di ba ang ginawa na sample 80%, 20%. Kung kukuha pa rin ng iba't ibang klaseng iba't ibang klaseng ratio nun, then our accuracy will fall between 89 and 92%. So yun ang 95% confident tayo that our accuracy will fall between these two. Ano yung no information rate? Yung no information rate, guys, hindi tayo gagamit ng ng predictors, no? Tingnan nga natin, let's see x tabs ng cardio natin, yung train, and then NSP. Oops. Right. Object, invalid formula. Ay, sorry. Mali. Dapat mali yung code ko. Sorry. Next tab is tilde, and then yung NSP data is equal to 10. Yeah. Ayan, okay. Yun na, tama. Sorry, mali yung data ko. Mali yung iniisip ko class, no? Alright. So this is the breakdown, guys, of our NSP data set train. 1, 3, 4, 8, yung 1, yung 2, 2, 2, 6, at saka 1, 4, 4. Okay, ano ibig sabihin itong no information rate? Since pinakamalaki si 1, what if ang gawin natin, ano na lang, yung n-row ni train. Okay, 1718 train. What if, i-predict na lang natin lahat na n yan? Diba? Wala pang hassle. Huwag na tayo gumamit ng model. Basta lahat, i-predict natin as n. If that's the case, guys, since pinakamarami si n, i-predict natin na lahat ng n yan, then our success rate will be 1348 divided by yung n row na kami natin, diba? Which is 1718. N row ni train natin, right? Yan. So that's 78.46. Yun ang ibig sabihin ng no information rate. Okay? No information rate, ibig sabihin, let's do away with the model. Huwag na lang, basta hanapin natin yung pinakamarami. No? Ano bang pinakamarami dyan? Si normal. E di, sige, gamitin natin lahat ng prediction natin normal. And then there's 78%. Okay? Pero guys, of course, delikado in what if pinari halos balance sila. Then, mababa yung rate na makukuha natin, no? na accuracy rate. And then dito guys, meron pa dito. No? Yan. Ito guys, meron dito. No? Sensitivity, specificity, positive predicted value, etc. Next meeting, we'll just discuss this. It's important for us to understand ano ba yung sensitivity, ano ba yung specificity, and then we finish this off with the rocks, no? Yung ano ulit yung plot ng rocks, naalala niyo yun? Yung under the curve yung rocks. So next meeting, we'll just finish this kasi mahaba-habang discussion pa yung mga rocks, siguro mga 1 hour pa yun plus this one. So hindi natin matatapos ngayon. So let's just end here, and then next meeting next Monday tapusin natin yung rocks, and then we go back to yung ano natin yung diagnostics ng multiple linear regression. Okay, and then after that punta na tayo sa iba pang regression and then time series sa tayo. Kasi po we'll look at mga lasso regression, Ridge regression, iba't ibang klase pang types ng regression na pwede natin gamitin. Okay? Guys?
Okay, sir.
Clear so far?
Yes, sir.